Imagine a single, permanent fix to the climate crisis, a limitless stream of clean energy that could power the entire planet forever from just one sun-scorched patch of desert. It sounds perfect, but building it would actually engineer a planetary disaster. Right now, human energy consumption is skyrocketing. As developing nations rightfully improve their quality of life, their demand for electricity surges in tandem. We need a massive, immediate shift to clean power to keep up. On paper, the Sahara Desert is the absolute best candidate for a global solar grid. It receives an unmatched level of direct solar irradiance and offers an almost incomprehensible expanse of empty land. It looks like the ultimate win-win scenario, a pristine, victimless victory that permanently solves our energy needs without emitting a single ounce of carbon. To understand the potential here, look at the sheer scale of the landscape. The Sahara covers over 9 million square kilometers. It spans 10 different countries and takes up almost a third of the African continent. It's actually larger than the entire country of Brazil. To match global energy demand, we only need to cover 5.5% of the Sahara, an area the size of Spain. Even quadrupling that footprint to 20% for future demand, maintenance, and research leaves an abundance of untouched sand. Plus, the region is practically empty. If you exclude the Nile River Valley, only about 2.5 million people live here. That's roughly 1 person for every 4 square kilometers. A solar farm this massive wouldn't displace communities or disrupt human life. So we have the space, we have the sun, and we have the technology to do this without bothering a single soul. Why are climate scientists terrified of actually building it? The answer comes down to a property called albedo, which is essentially a surface's ability to reflect light. Light-colored desert sand has a high albedo. It bounces a huge amount of solar heat right back into space. But solar panels are bark. They are designed to absorb light, which means they also absorb and trap heat. By covering 1/5 of the Sahara in dark panels, we dramatically reduce the desert's reflectivity. This causes a severe localized temperature spike, warming the immediate area by roughly 1.5 degrees Celsius. This cross-section diagram illustrates the meteorological reaction. The intense local heat widens the temperature gap between the blazing desert and the cooler surrounding ocean. This stark difference drops atmospheric pressure, creating a vacuum that pulls moist ocean air inland. Once this air hits the superheated desert, it rapidly rises, condenses, and falls as heavy rainfall. In our attempt to build a simple energy plant, we accidentally reverse engineer the local weather system, transforming an arid wasteland into an active storm zone. And then biology takes over. That new rainfall causes dormant seeds to sprout. Because green plants are much darker than sand, they absorb even more heat, triggering further evaporation and pulling in more rain in a runaway feedback loop. This process closely mirrors the African humid period from about 5,000 years ago, when the Sahara was naturally covered in lush green vegetation. But creating a new green oasis comes at a steep planetary cost. That excess heat doesn't stay local. Our 20% coverage model pushes global average temperatures up by nearly 0.2 of a degree. Atmospheric and oceanic currents carry this excess heat away from the equator, pushing it outward until it concentrates disproportionately at the planet's poles. This sets off another devastating albedo effect. The incoming heat targets the Arctic, melting highly reflective white sea ice and exposing the dark ocean water underneath. That dark water then absorbs even more solar radiation, rapidly accelerating the melt. By deploying what we thought was the ultimate weapon to fight global warming, we accidentally trigger a planetary heat wave and fast-track the destruction of the ice caps. Earth's weather operates as a closed system. Moisture doesn't just appear out of nowhere. If you artificially force heavy rainfall into one region, you have to steal it from another. Pulling massive storm systems into the newly green Sahara aggressively disrupts natural precipitation patterns in the tropics, plunging the Amazon rainforest into severe, prolonged drought. But water isn't the only thing the Amazon relies on. Every year, wind sweeps millions of tons of dry Saharan dust across the Atlantic Ocean. This blowing dust is a massive, vital supply of phosphorus and airborne nutrients, essential for feeding both marine life in the ocean and the dense vegetation of the Amazon basin. When we turn the Sahara green, plant roots and heavy moisture anchor sand to the ground. That effectively shuts off the nutrient pipeline, starving terrestrial and aquatic plants half a world away. The ultimate tragedy of this mega project is that fixing the harshest desert on Earth directly causes the dehydration and starvation of its most critical rainforest. Let's tally the final bill. Attempting to power our grid with a single colossal solar farm results in a melting Arctic, an overheating globe, and a dying Amazon. It highlights a persistent blind spot in human psychology. We naturally crave an easy silver bullet to solve our biggest crises, which makes it easy to ignore the complex math of reality. We cannot treat the Earth like a massive battery slot waiting for a plug. Our planet operates as a highly sensitive, intertwined biological and atmospheric network. Surviving climate change requires nuanced, careful, and distributed engineering. Because, as a Saharan solar farm proves, sometimes the most tempting cures are far worse than the disease.